These notes are for 6.2, area of sectors. So this is specifically dealing with sectors of circles. So a sector is a section of a circle bounded by a central angle and its intercepted arc. Think of a sector like a slice of pie. So the area of a sector has a formula. So if you think about the area of a circle, area equals pi r squared. But that's for a whole circle. So if a circle is 360 degrees, if I have a whole circle that's 360 over 360, that's 1. That's why we don't write this fraction. But if it's any other part of a circle, then x is the part of the circle that we have, the arc, and r is the radius. So we're just going to apply this formula over and over to find the area of the shaded pieces. So if you look at BC, BC is this part right here. That's our radius. We've talked about that before. So formula, area equals, what's our arc? Well, this is a central arc. That means the arc and the angle is equal to the arc. So our arc is 51 times pi times 16 squared divided by 360. So if you use the fraction key on the calculator, you can do that all at once. But for at least a couple of examples, I'm going to do just the top so that I get 13,056 pi divided by 360. So that was multiplying 51 and 16 squared to get 13,056. And then we divide by 360, and I get that the area is 113.94 feet squared. Don't forget that because it's area, we've got to go with square units. That's it. We're just finding the piece of pie that fits our that's our shaded part using the formula. So in most cases, you're going to be given the radius or the diameter. Here's PQ. Here's my radius. Here's the central angle, which means that the arc is the same thing. And now we just plug it in. Area equals 139 times pi times 22 squared divided by 360. So we have our arc, we have pi, we have our radius squared, and we have the total degrees possible in a circle. Putting that in the calculator, the top row comes out to 67276 pi divided by 360. And when simplified, we get the area is 587.09 centimeters squared. It really is about knowing where the numbers go in the formula for ease. Looking at number 3, JK. Here's our radius, which is 3. Our arc is 84 degrees because it matches our central angle. The area equals our angle, 84 times pi times our radius squared divided by the total angle degrees available in a circle. That's 756 pi over 360. That's 6.6 millimeters squared. Now, for number 4, we're going to take it a step further. This side is 126, but I don't want that side. I want the shaded side. So to find this reflex angle, remember that word? Reflex is bigger than 180. That's 360 minus 126. So this side is 234. That's the angle I'm going to use. So area equals 234 times pi times 13 squared. My pi looks bad. Divided by 360. That's 39,546 pi divided by 360. Remember, I'm just getting that by multiplying this number and this number to get here. And then when we simplify that, I get 345.1 yards squared. So the additional step here was having to find what the angle was that I need. You were given enough information, you just needed to know that you had to find it. Number 5 is similar. I'm given just the tiny little piece, but what I'm looking for is this big reflex angle. So this angle is 360 minus 42, which gives us 318 degrees. So the area is 318 times pi times our radius is 9 squared divided by 360. Multiplying out the constants, we get 25,758 pi divided by 360. So I'm given an area of 224.78 inches squared. So again, all we had to do was know how to find this reflex angle. Number 6 goes back to I'm already given the angle. So if here's the angle, here's the arc. Here's my radius of 28, just the formula. So I could really write this as 28 out of 360 because that's how many degrees out of a full circle I have. Oops, that's wrong, not 28, 115. So I have 115 degrees out of a full circle times pi times my radius squared. This is the same thing as what I wrote before when I put it all over 360. It equals the same thing. So I get 90,160 pi divided by 360, and that is 786.79 meters squared. Now, number 7 starts with some of your favorite things, decimals. So, remember this is the angle, that's why it has a little arrow here. ST, my radius, is 32.5. So my area equals 29 degrees times pi times 32.5 quantity squared divided by 360. That's 30631.25 pi divided by 360, so that I get that my area is 267.31 feet squared. The only difference is at that time we dealt with decimals. Ugly, but not a big deal. Number 8, again, we're given the angle that we don't need. So if this piece is 90, then the reflex angle is 360 minus 90, which is 270. So that's the angle that I use. 270 times pi times my radius is 29.5 squared divided by 360. That gives me 234,967.5 pi over 360. That's 2,050.48 miles squared. For number 9, again we have a decimal. I'm given the angle that I need, which means that the arc is the same. Don't forget that. If it goes through the center, the arc is the same. So my area is 72 times pi times 15.1 squared divided by 360. That's 16416.72 pi divided by 360. That's 143.26 inches squared. Number 10. So I'm given the angle that I don't need. The big reflex angle in this case is 341 degrees. I don't need that one. I need the other one. So this piece right here is 360 minus 341, which is 19 degrees. So when I fill this out, area equals my arc, which is 19, times pi times my radius, 4.7 squared. This is my r, divided by 360. Constants come to 419.71 pi over 360. So that my total area is 3.66 kilometers squared. So it's just a matter of plug and chug. The only really tricky thing about this is knowing the formula and where to plug things in. So now let's take it one more step and look at some problems that require that you go another step. So now I have more than one shaded region. But if you'll notice, what kind of angles are formed by these two intersecting lines? These are vertical angles, which means this is also 46 degrees. So that means my arc is 46 and this arc is 46. So technically, my total arc is 46 plus 46, which is 92 degrees. So as long as I know one arc, I can either find one and double it, or I can just double it and then find the total area. So I'm going to do that. So area is, my total arc is 92 times pi times my 7 squared, because remember this is my radius, divided by 360. That gives me 4508 pi divided by 360. So my area is 39.34 centimeters squared. So the only tricky thing here was that I added them together to get the total area, because area is just whatever portion of the circle I have. It doesn't matter that it's in two pieces. It just matters what my total area is. So when we look at number 12, we're going to do something really similar. So again, here's my radius. If this is 113, then this is 113. So my total arc is 113 plus 113, which is 226. So that's my total shaded area. So my area is 226 degrees out of 360 times pi times my radius, which is 30 squared. I can put that all in the calculator just like that using the fraction key and skip that second step that I've been writing to get that my area is 443.75 feet squared. So on an exam, especially when I'm giving you partial credit, you want to be able to at least show me how you plugged it in so that I know that you understand the formula. It's good to show me that you know how those things added up, where they came from. You want to show me as much as you can on any exam we have. So number 13, like we always do, takes it one more step. So if this is 143, this white part, then this white part is also 143. But that's not our shaded areas. So then I know that this line cuts the circle in half, so this is 180. So that this piece is 180 minus 143, which is 37 degrees. So if this is 37, this is 37, so that my total arc is 37 plus 37, which is 74 degrees. So again, I don't need to know how much is in each piece. I just want to know the total area that I'm going to talk about. So that's 74 pi times 10.4 squared divided by 360, which again, doing that all in the calculator, one step, 69.85 inches squared. Okay, now number 14 does it backwards. Not only are we not given the angle we need, but I'm going to shade most of it. So the easiest way for me to do this is 17 and this is 17. So that's 360 minus 17 minus 17, which is 326 degrees. That's how much of a circle I'm gonna shade. So my area equals 326 out of 360. Remember, fractions are always just how much I want versus how much I have, times pi times my radius of 43 squared. All in the calculator, all at once. 15.05 meters squared. So if you're looking at these, the biggest trick once you get past plugging it in is knowing where this number comes from. How much of a circle do you have? All of a circle? That's 360 over 360, that's 1. That's why we don't write that. If you have half a circle, that's 180 over 360. That's why we divide by 2. Is it a quarter of a circle? Is it 20 degrees out of a circle? So that's what we're looking for, is just to figure out which piece we're trying to find. So JM takes it one more step. So it's pretty easy to see that this piece is 180 degrees. You can't see that. Let's try again. This piece is 180 degrees. That's half a circle. And this piece is 58. So 180 plus 58 equals 238. That's how much is shaded. So my area is 238 over 360 times pi times 10 squared. So in the calculator, you would use a fraction, 238 over 360 times pi times 10 squared, and you would get that our area is 5192 millimeters squared. Now, for the last one that we have, it says that this is 62 So this is 62. So what these little lines mean is that all three of these arcs are congruent. So it means that all of them are 62 degrees. So our total arc is 3 times 62, which is 174. So my area is 174 degrees out of 360 times pi times our radius 12 squared. So all in the calculator all at once, 218.65 centimeters squared. That's it. That's how you find the area for a sector or part of a circle. Using the formula, what piece or fraction of the circle do I have? And then pi r squared is the regular formula for the area of a circle.